amounts, but like for the typical customer scenario,
Oh,
what does it cost you to launch, and what do they pay?
What does it cost us to launch?
Well,
I mean,
in the-
those, sorry,
Yeah,
go ahead.
like, so when you're in steady state, when you're actually in, what's the projections in 2016?
I'm sorry,
For the cost, your cost to launch the
so
satellites
what are our
versus-
margins per
Yeah,
flight?
that's
I mean, that's something that we typically don't share in a public forum. I'm happy to answer that. And it's in the business plan as well, so I'm happy to answer that later. I can write a number down for you. Yes.
Can you talk a little bit more about the first flight that you've had so far? I saw that was mentioned on there. Maybe what the attributes of that flight were, and how much more development you guys need to do before.
Okay, so yeah, I can clarify where we're at, what we've done, where we're going. So we haven't flown anything yet. We're flying in January, an inert test article, which is a mock-up of the GOLauncher 1. So it's taking a dummy, essentially, integrating it with the aircraft, operating it, handling all the airborne operation side of it, while the propulsion development is going on under separately funded development efforts in our partners, specifically Ventions. So GOLauncher 1 is meant to, again, stand as a risk reduction step to GOLauncher 2. So the rocket stage that we use for GOLauncher 1 is very traceable to the upper stage of GOLauncher 2 in terms of scale, technology, configuration, everything. The avionics are the same. The aircraft is very similar. And it's in terms of the organization that we need to build to offer a launch service, we really gain that experience through flight. So we're kind of doing that incrementally.
I'd like you to talk about the risks, primarily, I guess, in terms of safety, liability,
Okay.
those kinds of things, and any other risks that, but those risks particularly, because it seems to me that you do have a lot of risks
Okay,
associated with
so
this.
in terms of liability, are you talking about insurance of our system, our payloads, our pilots, our internal people?
What happens if it falls instead of launches?
Okay, so I mean, in general, we kind of there's plenty of precedent for this on both the aviation side of the house, just for operating the aircraft, as well as the space side. Orbital Sciences has done something similar like this, through Pegasus. So we will follow those standard practices that have already been implemented, safely so far. The fact that we operate out of coastal spaceports in general, so the launch license that the launch licensing process that we go through with the FAA to bring this system to market ensures that the maximum probable loss or things that are associated with the insurance that we need to file, everything is done. So I'm kind of rambling a little bit. It's kind of a broad question. So
I'd like to build on that
Sure.
just slightly. Can you go back to the financial projections, please?
Yeah.
And I'm going to try to tie this all together. I think what her major question is what sort of regulatory hurdles do you face? Where
Okay.
are you within that pipeline?
Sure.
What might that cost? And then that's what I want is that graph right there.
Okay, sure. Yep, it's going back.
And then I guess sort of related to that is, as you look at more of a global marketplace versus a domestic marketplace, what are those regulatory challenges in an international market?
Okay.
And do you need that international market to hit your projections? I know that was like 57 questions. Sorry.
Understood. Yeah. Okay. That's clear though. I think those are individual points that I can address pretty clearly. So the regulatory hurdle that we have to get over is with the FAA. Before we can offer this system commercially, we have to obtain what's called a launch-specific license, and eventually moving to a launch operator's license. So that's the thing that allows us to make money on the regulatory side of the house. So when the FAA is happy with the engineering that we've done, the tests that we've done, and so forth, that prove that we can operate this system safely, they'll hand us a license that say, yes, you can go fly this payload or your payloads. So that's the general regulatory hurdle that we have to get over. Our steps in that process, the first one is a pre-application consultation, which we conducted in January of this year. So we have a working relationship with the FAA to work ourselves through this process. They're involved in all of our development steps, essentially the flight program that we have over the next 3 years. They're present through all of that, so we keep them informed. They work with our suppliers as well. So that's generally how we approach licensing. The next one.
Sure. So you've got projections here.
Yep.
And
Oh,
assumingly that accounts for your domestic regulatory hurdles.
Yes.
Does domestic market get you to 50 million?
Yes, so everything that is involved in our our market projections is domestic and commercial. So we have specific letters of intent from domestic commercial companies. So international payloads, will tend to come in through our aggregators. So that's our way to move to that market. And TIVAC is a kind of a world-renowned organization for doing that, bringing them together. So no, there are additional international customers outside of the data that we show, as well as our flight rate projections. There's also the military market, which is not here, but it's not. We've chosen to attack the commercial market first. Is there any? Maybe there's one more. Okay.
How much of your engineering development is left? 10%, 50%? Are you almost there? You know, how much more does that 6.7 million do you need to go?
Okay. Well, I can talk to that. Maybe less than percentages, more specifics. $6.7 million gets us through GOLauncher 1, and that's maybe 2/3 of that. The rest of it is continued progress on GOLauncher 2. So when we fly GOLauncher 1, we will have flight proven the only propulsion system that hasn't been flight proven already, or tested already, the avionics system for the vehicle, flight controllers, algorithms, guidance, so forth. Launching a rocket from an airplane, so all the integration that's associated with that, as well as kind of our internal launch operations architecture. So we've kind of designed, we started with Go2, designed that system around as much of the existing technology as we could, and brought it down to Go1 and said, what can we do right now? So the aircraft for GOLauncher 1 exists. It's modified already. We don't have to sink any capital into doing that. So we've built Go1 around that constraint so that we can demonstrate everything that we need to do technically, all the milestones. And then when we get to Go2, everything is.
So do you potentially need some more investment for GOLauncher 2?
Oh, so yeah, I can talk to. Yep, it's on the last slide here. So everything I talked about for GOLauncher 1 and the inert test article that we're flying next year, that's rolled into the 6.7 million that we're looking for right now, all the way through commercial operations, the entire bank of capital that we need. We need an additional 11.3.
AJ, what about the plane? It doesn't seem like, to me, a plane that size costs 6.7 million. It costs way more. So what's the arrangement with the plane?
We're not buying the plane. We are wet leasing the plane from our partner, Calspan. So we don't have to carry the ownership and maintenance and so forth associated with owning an aircraft.
All right, that has to be the last question. Thank you very much.